Okay, so what you guys missed in class today was essentially going over lines and using them as a reference for angles. And the first thing we're going to be talking about is what is an inclination. So that's the definition. The inclination is the angle formed by a line and the y-axis. Now, sorry, not the y-axis, the x-axis. What we have to be careful here is it has to be a positive angle. If it's a negative angle, we have to do some math on it. So let's take an example. Let's just take a look at what we're talking about here. Suppose you have an x-axis and a y-axis, and then you have some random, some arbitrary line drawn like this. Now this line has a slope, so it has a slope of, we would say, rise over run. So we have a slope where we go up and then we go across, so rise and run. But it also has an extra part to it, this angle right here, this angle theta. And what we want to do is we want to define what that angle theta is. Now, if we take a look at this line, what we could do is we could take a point here, and then we could say, okay, if we run this way and rise this way, you'll notice we get a right triangle. Now, not only do we get a right triangle, if we continue to rise and run, so run this way and rise this way, we actually get the same exact angle, and we get common triangles or similar triangles where the sides will retain their proportions. So what we're going to do is we're going to use that fact, that idea, to write the equation that the angle of inclination, if we take the tangent of it, so if you take the tangent of the angle of inclination, what you'll end up getting is the slope. And that equation right there is a really important equation for us to just to ground our, I guess, our work before we get into polar coordinates. So we have tangent of theta, where theta is the inclination angle or angle of inclination, or just inclination. So our inclination is going to be theta, and m is just our traditional slope. And our first example, example number one, what we have here is we have just a general equation. So suppose we had the equation y is equal to, actually let's make this a little more complicated. Let's make this 2y minus 3x is equal to 18. And we were trying to find the inclination. Well, what we'd want to do is we want to find out what the slope is. The fastest way is to set y equal to the equation. So we have 2y is equal to 3x plus 18. Divide both sides by 2, and we get y is equal to 3 over 2, x plus 9. Using this right here, we can say that we now know that the tangent of theta, the tangent of the inclination, has to equal 3/2. And now we solve this. We find that theta is equal to the inverse tangent. Theta equals to the inverse tangent of 3/2. So we take out our calculator and we make that calculation. So we're going to take the arctangent of, the arctangent of 3 divided by 2. And what we end up finding is that our angle, our inclination, is 56.3 degrees. So we'll just write that in there. Theta equals 56.3 degrees. Now, we can do this anytime we have a slope. So the slope doesn't have to be limited to the slope from the equation. We can actually be given just an ordered pair. Two ordered pairs. So what if, problem number 2, so our second example, what if the 2 points we have were, let's say, square root 3 comma square root 2, and we were trying to find the angle of inclination, or the inclination, from that point to, let's go negative 5 comma, let's go up to 7. So let's say we had that. Well, we could find the slope of this, so we could say that the slope equals root 2 minus 7 over root 3 plus 5. And then all we have to do now is you set it to the equation. Tangent of our inclination, tangent of our theta, is equal to root 2 minus 7 over root 3 plus 5. And then we get theta equals the arctangent of root 2 minus 7 over root 3 plus 5. We take out our calculator and do a little bit of calculation on there. Now this here is going to be a little bit harder to write out. So give me a second. So we'll do arctangent of, we need a fraction. So it's going to be the square root of 2 minus 7 over the square root of 3 plus 5. And you'll notice that we get a negative angle here. So I'm going to go and write that, and we'll talk about what that really means How do we translate that? Because one of the things is that the angle formed by the line and the x-axis, the angle, the inclination, we always want this guy to here, no, sorry, not just that, but all of this guy here to be positive. Essentially, we want it to be between 0 and 180. So that's the angle of inclination that we're looking for, is something that's between 0 and 180. I forgot what the answer was, sorry. We got 39, let's say 39.7, so we got negative 39.7 degrees, so we can write theta equals negative 39.7 degrees, but under the stipulation that the inclination has to be a positive angle between 0 and 180, what we have to do is we have to think about, well, what does this really mean for us? So what if we were to take our x-axis and our y-axis and then graph these ordered pairs right here? So we'd have that point right there, some root 3, root 2, and then negative 5, 7 is some point that's right there. So what we would get is a line that kept going this way, and get a line that kept going this way, and we have to figure out this angle. Now what we ended up finding is this angle right here. So this angle came out to 39.7, and that's not what we want. So the quick end of it is looking at this. We know that this is 39.7 using the vertical angle theorem, and what we can say is that anytime that the angle is negative, we can rewrite it as 180 degrees minus the 39.7. So we can essentially add that negative angle to 180, and this will give us our inclination, which comes out to 140.3 degrees. So our inclination for these 2 points right here is going to be 140.3. So this is the first video of 3. This is for inclination. The next 2 topics are going to be finding the angle between 2 lines. So rather than finding the angle of inclination or the inclination of a single line, what if we had 2 lines? And then the final video will be on how to find the distance between a point and a line using just the equation of the point and the line and manipulating it from there. If you have any questions, please email me, and best of luck on the SBAC.